NASA is planning an ambitious mission that will see a robotic spaceship visit an asteroid to create an orbiting base for astronauts. The robot ship will pluck a large boulder off the space rock and sling it around the Moon, becoming a destination to prepare for future human missions to Mars. NASA also plans to study the asteroid and test deflection techniques that one day may be necessary to save Earth from a potentially catastrophic collision. Now the space agency has created a mock-up of its robot arm and tested it using a mock asteroid boulder at the space agency's Robotic Operations Center in the Goddard Space Flight Center, Maryland. The mock-up helps engineers understand the intricate operations required to collect a multi-ton boulder from an asteroid's surface. The hardware involved here includes 3 space frame legs with foot pads, 2 7 degrees of freedom arms that have with microspine gripper hands to grasp onto the boulder. The so-called asteroid redirect mission is estimated to cost about $1.4 billion, not including launch costs, and is targeted for liftoff in December 2021. Following a key program review, NASA approved the asteroid redirect mission in August to proceed to the next phase of design and development for the mission's robotic segment. ARM is a 2-part mission that will integrate robotic and crewed spacecraft operations in the proving ground of deep space to demonstrate key capabilities needed for NASA's journey to Mars. The crewed segment, targeted for launch in 2026, remains in an early mission concept phase or pre-formulation. This is an exciting milestone for the asteroid redirect mission, said NASA Associate Administrator Robert Lightfoot. Not only is ARM leveraging agency-wide capabilities, it will test a number of new technologies already in development. The robotic component of the ARM will demonstrate the world's most advanced and most efficient solar electric propulsion system as it travels to a near-Earth asteroid. NEAs are asteroids that are fewer than 121 million miles from the Sun at the closest point in their orbit. Although the target asteroid is not expected to be officially selected until 2020, NASA is using 2008 EV5 as the reference asteroid while the search continues for potential alternates before beginning its trip to lunar orbit. The ARM spacecraft will demonstrate a widely supported asteroid deflection technique called a gravity tractor. The spacecraft plus the mass of the captured boulder will create a small gravitational attraction to alter the orbit of the large asteroid. After collecting a boulder from the asteroid, the robotic spacecraft will slowly redirect the boulder to an orbit around the Moon using the Moon's gravity for an assist, where NASA plans to conduct a series of proving ground missions in the 2020s. There, astronauts will be able to select, extract, collect, and return samples from the multi-ton asteroid mass and conduct other human robotic and spacecraft operations in the proving ground that will validate concepts for NASA's journey to Mars. NASA also considered bagging a smaller asteroid and relocating the entire body into a high orbit around the Moon. After extensive studies, NASA opted to collect and move a boulder, a mission that will cost about $100 million, $80 million more, but which better prepares the agency for the ultimate goal of landing astronauts on Mars. They're the kind of things that we know we're going to need when we go to another planetary body, NASA Associate Administrator Robert Lightfoot told reporters on a conference call in August. An asteroid or comet smashed into the planet about 65 million years ago, leading to climate changes that killed off dinosaurs and most other life on Earth. So far, NASA has 3 candidate asteroids but does not expect to make a decision about where to fly before 2019. The mission involves flying a robotic spacecraft powered by solar electric propulsion to an asteroid for an extensive survey. Once a target boulder was selected, the probe will hover down toward the surface and deploy a pair of robot arms to grab hold of a 6.5 to 13-foot wide boulder. I'm going to have multiple targets we can assess which one we want to go after, and I then have 3 to 5 tries to hit it, or I can move on to a different one, Lightfoot said. The captured boulder, which would remain attached to the probe, would then be nudged into an orbit circling high around the Moon, a maneuver expected to take about 6 years. The probe would include a docking ring so a NASA Orion spaceship carrying 2 astronauts could reach the asteroid, a mission targeted for around 2025. NASA's ultimate goal is to send humans to Mars, and they say the asteroid redirect mission will be an important stepping stone towards getting there. A number of new space flight capabilities will be tested in the 2020s as part of the mission, which will involve redirecting an asteroid to orbit the Moon and sending humans missions to explore it. NASA plans to launch an armed robotic spacecraft to rendezvous with, capture and redirect an asteroid by the end of this decade. The spacecraft will redirect it to a stable orbit around the Moon called a distant retrograde orbit, one that orbits the Moon very widely, coming quite close before extending out much further away. Astronauts aboard NASA's Orion spacecraft, launched from the upcoming Space Launch System rocket, will then explore the asteroid in the mid-2020s at the furthest point in its controlled orbit around the Moon. Within the papers, authors explain the current work taking place across the country to examine options for these robotic and crewed missions. This includes advanced solar electric propulsion, one of the critical technologies needed to send larger payloads into deep space and to the Mars system. SEP, or ion propulsion, creates thrust powered by solar arrays, which transforms sunlight into electromagnetic fields that accelerate and expel charged atoms. This is a very efficient way to power a spacecraft and significantly cuts down on the amount of fuel a spacecraft needs to carry, which can be heavy and expensive to launch from Earth. Current studies at NASA detailed in the papers are examining ways SEP will be used to power the armed robotic mission. NASA was also working on a mission concept that would fully enclose a large asteroid using an inflatable system, and the other would capture a smaller boulder from a much larger asteroid using robotic arms. The armed crewed mission, in which astronauts will explore the redirected asteroid around the Moon, provides unique opportunities to test human spaceflight capabilities as well. The papers detail current work underway at NASA to upgrade spacesuits in preparation for the first spacewalks in deep space since the 1960s and farther from Earth than ever before. Concepts for new hardware to dock the crewed and uncrewed spacecraft together are also in development. This will allow the crew aboard Orion to attach to the armed robotic spacecraft and study the asteroid. This could be later used to connect Orion with a deep space habitat or stepping stone on its way to Mars, or even station cargo and fuel depots in strategic places such as lunar orbit. Astronauts returning home with samples from Mars will hold a treasure trove of research scientists will study to unlock new knowledge about Mars and the solar system's history. As well as this, returning asteroid samples will help NASA develop tools and techniques for future space exploration. This early experience with raw materials could also help advance our ability to make use of natural resources in space. Rocky bodies like asteroids and our Moon could hold enough oxygen and hydrogen to create breathable air, drinkable water, or even components for rocket fuel. There also is growing interest in the commercial space industry to potentially mine asteroids for resources in the future. With this in mind, some of the papers outline ways in which our might benefit future commercial activities at asteroids, namely collecting resources for use back on Earth or in space.